So we're going to solve some radical equations, meaning they have a radical sign or square root sign in them. So remember, our steps are to isolate the square root. So I'm going to go ahead and highlight all of the square roots so I know which portion needs to be isolated. Now we're going to solve it like it's an algebra problem. We need to get the square root by itself. So on this first problem, it's already by itself. So I'm ready to go ahead and square both sides. So I'm going to go take that to the second power and take that to the second power. Let's make it a little bigger so we can focus on it. So then when we rewrite it, what you're supposed to remember is that this 2 cancels out this square root symbol. And so what we're left with is just the 2x minus 5 equals 7. And now it's just a plain old two-step algebra problem, so we're going to go ahead and solve it by adding 5 to both sides, dividing by 2, and we put in x equals 6. Now we're going to check it. We're going to go ahead and put it in there. So the square root of 2 times 6 minus 5. And again, the purpose to check is to make sure that what you have as a solution inside the square root does not end up being a negative. And so you can clearly see that that would end up being 12 minus 5, which really is the 7, so it checks. When we look at the second problem, it's just one step more difficult. You'll notice that there's a plus 13 on the same side as the square root symbol. So our first step then is going to be to subtract 13 from both sides. And we now have the square root of h minus 7 is equal to 10. Now we're basically at the same place that we started on question number 1. So we're going to square both sides, because that is the opposite of taking the square root. So the square and the square root cancel, and I'm left with h minus 7, and 10 times 10 is 100. We're now going to add the 7 to both sides, and we end up with h equals 107. And so again, we're going to go ahead and check it just to make sure that when we do the square root piece, we have 107 minus 7, which we do know is the square root of 100, which is 10. And 10 plus 13 really does check out to the 23 that we started with. All right, so let's try this last problem. Now this last problem has 2 things happening over there by the square root symbol. They are subtracting 8, and do you see the 6 out front? Remember, that means that it is 6 times the square root of 3x plus 1, all subtracted by 8. So again, just like in a two-step, you're going to get rid of the adding or subtracting first. So we're going to go ahead and add 8 to both sides. We now still have the 6 and the square root of 3x plus 1. Again, I'm going to go ahead and just highlight that so you can still see that I have this, and it's not alone. It's not isolated yet. So since they are multiplying by 6, I will divide everything through by 6. That way my 6's will cancel, and I'll be left with the square root of 3x plus 1, and that would be 4. Now I need to get rid of the square root, so we're going to take it to the second power, and we have 3x plus 1 equals 16. Now I still have to solve the whole algebra problem, and again it's another 2 steps, so we're going to go ahead and do all the steps. So subtract 1 from both sides, divide 3 from both sides, and we end up with x equals 5. And so what we're going to do is we're going to go ahead and substitute that back. I really don't have any concerns because I can see that everything inside the square root is a plus, but I'll go ahead and show it just in case. So you have square root of 3 times 5 plus 1, which would be 15 plus 1, which is 16, and the square root of 16 is 4. And so as you're working it out, it really ends up being 6 times 4 minus 8, and that is 24 minus 8, which really is the 16, and it checks. So remember, isolate the square root. Once it's isolated, square both sides and solve the algebra problem.